If you've been around for a while, these might look familiar to you. These are some cool 84 by 48 LCD displays from Nokia. I think they're actually manufactured by Phillips, but these are surplus screens from Nokia. I think the cell phones were like in the mid to late 90s. Little 84 by 48 monochrome screens with a backlight, and they're pretty cool. This is the back of them. It's simple 8 pins. Might be a little hard to see. You can see it better in the pictures, but it's really simple 8 pins. It's a LED, clock, MOSI, DC, reset, SCE, ground, and VCC. It's really simple. They're basically a serial device. It has a clock, a send, and a receive, and then basically an enable bit you have to set, and then the other ones are for ground, power to the chip, and power for the LED backlight. There's LEDs, you'll see in a minute when I power it up. There's an LED in each one of the 4 corners, and it's a pretty decent looking display. So I sourced these from eBay, and I'll show y'all where I got mine, or a similar link to where I got mine. But they're also available at Adafruit and SparkFun. And the really cool thing about these displays is that there are a lot of them out there, because there were so many Nokia cell phones made back in the late 90s. They were pretty much the only brand before smartphones came out. Everybody had one of these little Nokia candy bar type phones. So there's a lot of these displays, and there's a lot of data out there, which makes them really good. There's a library for just about every hobbyist microcontroller out there. There's a lot of good example programs. These things are cheap because there's so many of them out there. I bought mine, 5 of them for $15 shipped from China. Now if you buy them from SparkFun or Adafruit, they're going to cost you about 10 bucks a piece. So this is the Nokia 5110 LCD at SparkFun, and I'm going here because they have some really easy to get to documents here about the LCD. But there's also, if you go to Adafruit, learn.adafruit.com. There's some real good step-by-step stuff here too. Let's see. Nokia 5110. I do have a caveat for y'all on that. Here we go. And here it is hooked up. And their Adafruit really did a lot of work with the libraries for Arduino. Like this splash screen is set to come up whenever you power up one of these things. Also, you see these up here. It looks like it has 16 pins, but there's really only these 8 pins here, because these are just probably for testing, because there's lines that run from here to the pin straight across, or maybe they set it up like that so they can get to the pins from either side depending on the application. So, and oh, here's an important thing to mention whenever you're using this LCD. If you want to use a backlight, that can draw up to 80 milliamps. 4 white LEDs at 20 milliamps each. The backlight pin is connected to a transistor, so you can PWM all 4 LEDs at once from a microcontroller pin. And I will back that up. You can, you'll see in a little while that how easy it is just to run PWM and then adjust the brightness like that. All right, and then she goes into the wiring and everything, and her headers aren't already installed, so she's doing that and using level shifters and whatnot. And that's where I kind of go back to the SparkFun, because their quick start guide for this is pretty good, and it's the same version I actually have. You can see they replaced their bitmap image there. Okay, now One important thing that you'll see from these websites, this is meant to be used with a 3.3 volt microcontroller. It's 3.3 volt logic levels. It does say that the maximum voltage is actually like 7 volts for the logic levels, but that's known as absolute maximum, and it'll probably shorten the life of the LCD if you use 5 volt levels. Not saying I won't, but you'll see this is pretty cool because at SparkFun I like this because it's showing like a 3.3 volt microcontroller being used, and they're just wiring straight up to the LCD. And here's an example of using 10k ohm resistors for current limiting, and they're just putting a resistor on each one of those logic level inputs there. So that's pretty easy too. Or here's another way. You can use these logic level converters, or I guess they might also be known as level shifters. And if you buy one from Adafruit, it does come with level shifters with it for free. So you may see me hook my pins directly up to from 5 volt microcontroller to the LCD, but I wouldn't recommend it. I'm not advocating doing that. They have a little test code down here and whatnot. We'll get into that in a little while. I mean, how many of these phones have you seen? I saw millions of these phones, literally. That's why there's so many out there. There's probably so many spare parts and just stock. Okay, so back to topic at hand here. They also have here, this is datasheet. It says integrated circuits. Oh, it's Phillips. Okay. The Phillips Semiconductor makes this, and this is published in 1999. So it was probably around before then too. But the reason I'm really looking at this data sheet is because this data sheet is like really, really awesome. It tells you everything you want to know about the chip. It's got a block diagram, like a functional block diagram of the chip. And it's got all the typical things you expect to find in a data sheet. But then it's got functional descriptions of each of the subsystems on the chip that are written for, it looks like to me it's written for people that aren't necessarily engineers, which is pretty odd. I mean, they really give some very educational information on this sheet. And look, here's an example of what what it looks like when you're actually generating an image. So they're showing the different rows and columns and the data that's going to be on those rows and columns whenever something's being written to the screen. They're showing the timings. See typical LCD driver waveforms. If you're looking at this on a scope, that's what you would see. And they actually get into the construction of the LCDs. I mean, I think and look, the actual addressing, least significant bit, most significant bit, the RAM format addressing. But they actually give you so much information here in this data sheet that they teach you how to use it, and I think they actually teach you enough in this data sheet where you could take this, if you had any sense at all, you could take this data sheet and write a driver yourself. But it's pretty cool. There's a lot of information here. There's as much or as little as you want in this data sheet. And here's the maximums I was talking about a minute ago. And these are, let's see. Now this is interesting. It lists the supply voltage LCD is max 10 volts. And these are absolute maximums, which means just slightly above that will probably instantly fry the component. Not kill it over a long time, but probably instantly fry it. So So it's showing a minimum high level input voltage of 0.7 volts, and then a high is going to match volts DD, which is from supply voltage here. VDD, just DD, so it's up here, which is +7. So that's where you get the maximum, absolute maximum of 7 volts. So anyway, great data sheet, I think. And I don't know if we showed this already. Where is it? They said they're all over the place. I bought mine from, I think it might have been this seller right here. This is not an endorsement for this seller, but I did get them. Check it out. 5 of these 84x48s for $14.66. That's a pretty good price. And the flexibility of these screens is incredible, as you'll see in a few minutes. Let me go ahead and get back to the camera and I'll show you how to wire this thing up. Okay, so wiring this thing up was pretty easy. Unplug this. In this case, I'm using Arduino Uno, and I will remind you again that you should probably use some current limiting resistors or level shifter here, because this is officially a 3.3 volt device. Whenever I wire it up into a long-term circuit, I will use some kind of current limiting, or voltage limiting, I should say. But this is really simple to wire up. You have 8 pins on the display itself, and pins 3 through 7 go to pins 3 through 7 on the Arduino Uno. The only difference is 3 and 4 on the Uno side are swapped. So 4 goes to 3 and 3 goes to 4 when you're talking about LCD to Arduino. Then you just give a, I'm giving a VCC of 5 volts in and a ground signal here. So now we've accounted for 7 of the pins. The only pin that's left is the only pin that we have left. I hooked. You can choose whatever pin you like, as long as it's a PWM pin. I hooked pin number 11 up to the LED connection on the LCD, and we're going to run a PWM signal there to control the backlight. But it's real easy. Basically, you got pins 3 to 7 going to 3 to 7, and then you got a VCC and ground, and then you have your PWM pin to control the backlight, and that's it. Okay, so now we're going to look at the code real quick, and before we start, I do need to show you guys the library. And your library location is going to be different, but on the OS 10, it's in Documents, Arduino libraries, and you just drop your libraries into this folder. And I had to rename these folders in this case because the folder names are kind of messed up. You just drop the libraries in, and I'll show you where I got them. Adafruit actually has them. Let's go back there. Learn. There we go. Adafruit has them. They're actually on I think GitHub. This is the actual Nokia 5110 LCD library, and to get this, if you're not familiar with GitHub, just click on zip and it'll download to your downloads folder, and then once you download that, you go to that folder that I was just talking about, and in this case you would just drag it over and then it's in there. It's a little different on Windows. On Windows, I think you have to go to your username. Then it's still going to be Documents. Actually, it might be the same path. It's username, Documents, Arduino libraries, I think in either case. And you just drag them in. And this file name right here is no good, so you have to rename to something. And once you do that, Arduino will automatically add that to your library for you. So, but I've already added that. You're also going to need this driver or library right here actually drives the chip itself. This Adafruit GFX is a generic library of graphics commands like draw circle, line, fill, rectangle, those kind of things. It's really nice. It's generic. It works across a lot of different drivers. So you need your hardware driver and then you need your graphics driver. So you can get both of those from Adafruit, and I'll show you where the graphics driver is. They probably even have a link to it from the hardware driver. Look, it's right here. You will have to download the Adafruit graphics core, which does all the circles, text, rectangles, etc. and get it from. And they give another GitHub, and same thing. You just hit zip, and you get it. So now we have our libraries. Close all this stuff up. And now that you have your libraries, what you can do, if you like to start, is you just go to File, Examples, and there's a nice little example right here called PCD test. You can go ahead and load that up and run it if you like. I'm not going to run that right now because I'm actually going to open a file I was working on. Here we go. There. But well, I still have the headers from the example in here. But you see, I'm just going to take you guys through a quick little bit of code, and I'll try and explain how it works very briefly. I've commented out a lot of this stuff, as you can see. You can reassign pins here if you want. Like I could have flopped 3 and 4 around right here if I liked. The important thing is you have to include Adafruit graphics and Adafruit PCD8544, which I believe is a controller that is on that board. And you're defining your pins here. I'll just kind of take you guys step by step. This has all been commented out by me. That's an actual bitmap image there that I'm not using. Okay, so we're in our setup here. And you'll see first this analog write. I'll go ahead and write a comment here now. But this analog write 11,20 sets I'm getting some weird stuff here. Still getting weird stuff here with this keyboard. And this is not just on the Mac. I actually had this happen on the on my Windows version. God, it does some weird stuff. Wonder if it's something to do with the screen sharing. I'm just not sure. All right. Anyway, I'm not going to comment right now on this stuff then. Anyway. You see analog write 11,20. That's a really dirty way for me to just set that LCD to a PWM of 20, which is running at about 10%, or less than 10% duty cycle if 254 is the max. And I find that's a nice dim level, but still very readable. Display begin, that just initiates the display. Set contrast 50. I haven't really seen a lot of difference in contrast values, and I guess that's because you're kind of just dealing with black and white. You're not even dealing with grayscale here because you're either setting your pixels on or off. So there's really not a contrast there. It's either on or off. So this doesn't seem to do much unless I'm misunderstanding. Display.clear display. Call to that function will just clear the display and the buffer. Look, clears the screen and the buffer, which you do need to keep in mind there's a difference between buffer and screen. I'll explain that in a minute. And this has all been commented out. That's just drawing different shapes and stuff in the example program. Okay, here's my program now. You'll see I have these number four for loops, and all I'm doing is I'm starting a line in the middle of the display, all the way out to the edge of the display, and then I'm having that line redraw just like a hand of a second hand of a clock, and it's just rotating around. And like this, I'll go through this draw line command real quick. Display.draw line 42, 24. That tells it to start at see x coordinate. That's x and y coordinates, by the way. The screen is 84 by 48, so 42, 24 is dead center of the screen, comma m, which is the value in this for loop, and I'm just sweeping m all the way across the screen. So it's going to draw a line from the center to m. So if you can picture that in your head, center to m, and then m goes all the way across the screen, that means we're going to be sweeping a line just like a second hand all the way across the screen. And the color here, black, this can either be black or white since we're using a monochrome mode. Then you'll see I do a call to draw clock. That's a little quick function I wrote down here. Draw clock. I just whip that up real quick. That puts a 12, 6, 3, and 9 on the screen just for fun. And you'll see I have display.setCursor and then coordinates again, and that's just starting the telling the program where I want to start this text at. This, and you can also set like the font size and things like that. But okay, and you'll see display.fillCircle. And then if you look at the display, I mean the example program, you can really figure all these commands out. That's what I did with this. Display.fillCircle, and then it basically puts it 2 is the radius, color is black, and then you see height, display.height divided by 2, and display width divided by 2. That's another way you can put it in the center without even knowing the size of the display. And you'll also see every time you make a call to draw a clock, I can actually change this, display.display. Every time you set things up to be displayed on the screen, as I did here, like whenever I do display.setCursor and display.println12, it doesn't actually put that to the screen. What it does is it saves this to the screen buffer. This 12 will get saved to that position in the buffer, and then the 6 is there, 3 is there, 9 is there. At this point in the program right here, there's still nothing on the screen that's been being written by this routine. So all this information is just going to the memory buffer. Okay, and then whenever we do display.display, what it does is dumping the buffer to the actual screen itself. So you're not writing to the screen until you do this command right here. And there are some other implications of that, like you can have things that are already on the screen, and then you want to add things without taking the things that are already on the screen away. Well, just don't clear the screen, add what you want to the buffer, and then use display, and both things will be displayed at once. Which is why I don't actually this will work, display.display, and then the other things that are going on with the sweeping hand, that can be separate. And you'll see as I sweep the hand, and I could probably, there's other ways to do this. See, I'm drawing the line, display.drawLine, and then I'm using draw clock, okay? Then I'm doing display.display, which I should take display.display out of draw clock if I'm going to do it like this, because I'm writing to the screen twice. So it's actually probably a little less efficient having display.display in the draw clock function as well. Then I have a delay here, 250 milliseconds. I'll work on that delay later. The idea is just to make it tick, and we're actually getting a tick because we're doing m equals n plus 3, so it's not smooth, it's kind of a ticking kind of thing. And after that, so after we go through this for loop here, this first one, you can see that it draws simply draws a line that extends from the center of the screen to the top left of the screen, and then that line sweeps across to the top right of the screen from the center. This next for loop takes the line from the top right to the bottom right. This goes from the bottom right to the bottom left, and this goes from the bottom left back up to the top left again where it all started. So that's why we have 4 for loops there. And every time it draws the way I have this set up, every time it draws the line, it draws the clock too, and it turns out that's not really necessary. Another way to do it, which I actually saw later, is you can just draw the clock once, then draw the line, and then draw another line where the line was when you want to erase it, but just draw it in white, and that'll effectively erase it without erasing all of your clock, all the rest of your clock, so you don't have to refresh the whole screen. So that's another way to do it, but this way actually works, as you'll see. So yeah, that's pretty simple code. It's pretty easy to use, and like I said, there's a draw circle and rectangle and all that other kind of stuff in that Adafruit graphics.h library. So it's pretty good. Let's go ahead and check it out and see how it runs. Okay, hopefully you guys can see this well. I think you can, and you can see now the 4 backlights there, and they're running, like I said, at less than 10% duty cycle. So you can really make those very bright if you want to. I didn't want to. But you see the animation is pretty good on this thing, and it's very readable. I mean, these were made to be able to read phone numbers in sunlight, so I think they're a pretty good deal. And I was able to do this quick little piece of code after just looking at the information for a couple hours. So I imagine after I get a little more experience, you can do some really cool things with this display. It's cheap, it's easy to use, and it's pretty universal. So check it out. Thanks for watching. Bye-bye.